Hello friends, welcome back to Online Maths Hub. We are going to be solving this problem right here. And so what we have here is m power 6 is equal to m minus 1 all power 6. Okay, we want to find out the values of m that actually satisfy this equation. This is an Olympiad maths problem, and so you want to make sure you actually understand how you can solve this kind of problem whenever you come across it. Okay, and of course I'm going to be guiding you as we proceed in this video. But just before we proceed, if you are new to our channel, do want to just hit the like button, subscribe to our channel, and also turn on the notification icon so that subsequently when I release new content, you actually get to know about it. And of course, if you are a returning subscriber, thank you so much, and also like this video as we proceed. Now, what I want to do is I want to start by writing solution. Okay, I'll repeat the question. M power 6 is equal to m minus 1 all power 6. Okay, so what I want to do now is to move this term at the right hand side to the left hand side, so that we're now going to be having m power 6 minus, so when this one crosses here, it becomes minus m minus 1 or bracket, and then power 6 is equal to 0. Okay, so I can actually write this m power 6 as m power 3. Okay, m power 3 raised to power 2, and I will also write this term that way, m minus 1 power 3. Okay, and I will raise to power 2. And obviously what you can see here is a difference of 2 squares, and of course you can remember that if you have a squared minus b squared, that this can actually be expanded as a minus b, and then a multiplied by a plus b. Okay, so I'm going to use this rule right here to expand this one, and in this case you can see here that our a is now, in this case, m power 3, and then our b is m minus 1 all power 3. Okay, so having written that, I can now go ahead to expand. So to expand this, I'm going to be having that a minus b here will now be equal to m cubed minus m minus 1 raised to power 3. Okay, and all multiplied by, so let me put this in bracket, multiply by a, which is m cubed plus m minus 1 squared. Okay, of course it's still equal to 0. You can see that the product of these two terms here gives us 0. And so we're going to be using the zero product rule, which basically say that if you have two terms multiplying themselves, it will only happen if one of the terms, that is, let's say a multiplied by b is equal to 0. This will only happen if either a is equal to 0 or b is equal to 0. So we want to find out which of these terms will be equal to 0. So picking this first case right here, I'm going to be having m cubed minus m minus 1 raised to power 3 is equal to 0. So let me call this case number 1. Okay, so we're going to simplify this and then find out the value of m that can actually make this term to be equal to 0. Okay, so clearly you also see that what we have here is difference of 2 cubes, and if you can remember also that a power 3 minus b power 3, if you expand this is going to be giving you a minus b, and then multiply by a squared plus ab, and then of course plus b squared. Okay, so I'm going to be using this expansion to also simplify what I have right here. Now first, in this case, you can see that a is equal to this m, and then our b is equal to m minus 1. Okay, so expanding this, what I will be having is m minus 1. Okay, and then let me still put this in big bracket, and then multiplied by a squared, which is m squared, plus ab, that is m multiplied by m minus 1, and plus b squared, which is m minus 1 all squared, equal to 0. We're also going to be using the zero product rule to simplify this, and so the first case here is what we have right here. So we want to find out whether this is equal to 0. This term here, or this particular term, is equal to 0. So we have n into m minus 1. Okay, it's equal to 0. Okay, so of course, which implies that m, open this bracket, minus m plus 1 is equal to 0. Okay, and obviously you can see that this is not equal to 0. This is actually 1, because this minus this gives us 0, and so this whole thing now gives us 1. And of course you can see that this is not equal to 0, so we can pick a solution from here. We now come back to this for the second case. Don't forget, whenever you have two terms multiplying themselves and they are equal to 0, is either the first term or the second term is equal to 0. So let's now check this case. Okay, so what we have is m squared, okay, plus m into m minus 1 plus m minus 1 squared is equal to 0. Okay, so we can go ahead to simplify. I'm just going to go ahead to open this bracket right here. So I have m squared plus m times m is m squared, then m times minus 1 gives us minus m, plus I also simplify this right here. And of course, the easiest way to do that is you multiply the first time by itself. Each time you have a polynomial of degree 2 and you want to multiply it, this is just a simple trick to do that. So you use this one to multiply, use the first time to multiply itself. So we have m times m, which is m squared. Okay, and then use these two right here to multiply the terms inside the brackets. That is 2 times m times minus 1. That will give you minus 2m, and then you use this second term to multiply itself, and that will give you positive 1. Okay, and it's all equal to 0. So clearly you can see here that we can sum all of this. So m plus m is 2m, plus this m we have 3m squared, minus m minus 2m will give us minus 3m, and then plus 1 here is equal to 0. So we have 3m squared minus 3m plus 1 is equal to 0. So clearly you can see that this is a quadratic equation. We can just go ahead to solve, and you can clearly see that it is not factorizable. So we're going to be using the general method, which of course sees that in this case our m is going to be equal to minus b, and then plus or minus the square root of b squared minus 4ac, 4 times a times c, and is all divided by 2 times a. Okay, so we're just going to find out the parameters. So in this case, our a is equal to the quotient of m squared, which is equal to 3, and our b is the quotient of m, which is minus 3, and then our c is equal to the constant here, which is equal to 1. Okay, so therefore our m is now equal to minus, and then minus b minus 3, okay, plus or minus the square root of minus 3 squared, and then minus 4 times a is 3, and then times c is 1. Okay, and is all divided by 2 times 1. And so simplifying, I'm going to be having that this is 3, and then plus or minus the square root of minus 3 squared is 9, and then minus 4 times 3 is 12, times 1 is also 12. It's all divided by 2, which is 2 times 1. Okay, so moving on, what I have here is a 3 plus or minus. Oops. Okay, sorry, what we have for A right here, for A, what we have here is 3. Sorry about that. So that we now have 2 times 3 here, and that becomes 6. Okay, so we now have 3 plus or minus 9 minus 12 is minus 3. It's all divided by 6. Okay, so simplifying for that, this is 3 plus or minus. Can actually split these to be root minus 1 and then multiply by root 3, so that when I multiply these two root right here, I'm going to be having root minus 3, and it's all divided by 6. Okay, and then of course this is 3 plus or minus root minus 1 is actually I. Okay, and then multiplied by root 3 divided by 6. Okay, so obviously the two values of m we are getting right here is equal to m plus I root 3 divided by 6, or 3 minus I root 3 divided by 6. Of course, you can also simplify for that to have 3 over 6 plus I root 3, or 3 divided by 6, and then minus I root 3 divided by 6. So which you can also divide to have that this 3 divided itself, 1 3 divided 6 here will give it to. So you now have that the m, that m eventually becomes 1 over 2, so this is over 6, plus I root 3, okay, divided by 6, or this is 1, this is 2, so we have 1 over 2 also, minus I root 3 divided by 6. So these are the two values of m we are getting right here. Okay, so having solved this, we can now come back to this place and then continue with the second case. Okay, so we're going to be continuing with this case. So we have case 2 here, and it is for m cube, okay, plus, this is what I'm picking right here, m cube plus m minus 1 squared. So this is cube, this is cube, m cube plus m minus 1 raised to the power 3, okay, it's equal to 0. Now we're going to continue solving here, and then we find out all the values of m that satisfy the equation we are solving. Okay, so moving on, you can also see that this is a sum of two cubes, and you can remember that if you have a power 3 and then plus b power 3, if you expand this is actually going to be giving you a plus b, and then a squared minus ab plus b squared. So this is what you're going to be having when you expand this. And so we're going to be using this expansion here to also simplify what we have up here. So in this case, let me write our a is equal to m, and our b is still equal to m minus 3. Okay, so we're going to be having here our a plus b now becomes m plus m minus 1. Okay, and then the second bracket a squared, that is m squared minus m into m minus 1, okay, and then plus m minus 1 all squared is equal to 0. Okay, so using the zero product rule, I'm going to pick this one. So m plus m minus 1 is equal to 0. And of course, or the second one, which is m squared minus m into m minus 1 plus m minus 1 squared is equal to 0. So I'm going to solve this one first. So that I have, if I open this bracket, I have m plus m minus 1 is equal to 0, which implies that this is equal to 2m minus 1 is equal to 0. This implies 2m. Take this, if I take this minus 1 to the right hand side, I have that this is 2m is equal to 1. And of course, obviously, dividing through by 2 gives us the fact that m is equal to 1 over 2. Okay, so of course this m is equal to 1 over 2. And now solving for this case right here, okay, we just go ahead to simplify this. So we have m squared. I'm going to open this bracket right here. Minus m times m is m squared. Okay, and then minus m times minus 1 gives us a plus m. Okay, then of course plus, I can also open this bracket right here, and then using the trick I just mentioned earlier on, the first time multiply is which is m squared, and then you use this 2 to multiply the product of the two terms inside the brackets. So I have 2 times m times minus 1, and that will give you minus 2m. Okay, and then the last term here, which is minus 1, multiply itself to have plus 1 is equal to 0. Okay, so moving on, what I'm going to do is to simplify. This one can actually cancel this, and then I'm left with this m squared. Okay, and then of course plus m minus 2m gives us minus m plus 1 is equal to 0. So that gives us another quadratic equation which is not factorizable. So using the formula method, which give us the value of m to be equal to minus m minus b plus or minus the square root of b squared, okay, minus 4ac divided by 2a. And so in this case, our a is equal to 1, that is coefficient of m squared. B is equal to minus 1, and that's the coefficient of m. And then c will be equal to the constant, which is just 1. Okay, so moving on, I'm going to substitute of this. Therefore, my m is going to be equal to minus 1 plus or minus the square root of minus 1 squared minus 4 times 1, okay, times 1 also, which is c, and it's all divided by 2 times a, which is 1. Okay, so moving on, what I'm going to be having is m is equal to, this gives me 1 plus or minus the square root of, this is 1 minus 4, okay, divided by 2, and this will be equal to 1 plus or minus the square root of minus 3 divided by 2. Okay, so splitting this square root negative 3, I'm going to be having that this will be plus or minus root minus 1 multiplied by root 3 divided by 2. Okay, so of course this is going to be equal to 1 plus or minus root minus 1 is actually I, and then multiplied by root 3 divided by 2. So obviously we are getting from here that the values of m is equal to 1 plus I root 3, okay, divided by 2, or 1 minus I root 3 divided by 2. Okay, so these are just the values of m which we've gotten, and of course I can go ahead to just highlight all of them here. So I'm going to put that in this rectangle over here. So we've gotten m1, m2, m3, m4, and then m5. Okay, so let me label them that way. Okay, so these are the first two values of m, and of course let me just put it right here. So m1 is 1 over 2, okay, plus I root 3 divided by 6, and then for m2 this will be 1 over 2, okay, minus I root 3 divided by 6 also. And then looking at this place also, you see that this is the second value of m, that is m equal to 1 over 2. So I'm going to put it as I'm going to put it as m3. So this is m equal to 1 over 2. And then finally, the last values of m which we've got is this. Okay, so which of course I can also rewrite all of this to be equal to 1 over 2 plus I root 3 divided by 2, or 1 over 2 minus I root 3 divided by 2. So let me just put it right here. So we have 1 over 2 plus I root 3 divided by 2. And then this one, 1 over 2 minus I root 3 divided by 2. So these are the 5 values of m which we've gotten that satisfy the equation we are solving. So, and that is basically how you solve this kind of problem. Let me have your thoughts in the comment section. If you've understood what we've solved, don't forget to subscribe to our channel, like this video, and also turn on the notification icon so that subsequently when we release new content you actually get to know about it. Thank you so much for watching, and I'm going to see you guys in my next video. Bye.